So there's two basic scenarios that we're going to talk about. One is if you have compensated your data on your acquisition cytometer and would just like to view it, potentially edit it, although we'll talk about maybe some reasons why we don't want to do so much of that, or change it, apply a different matrix and so forth. And the other is doing compensation from scratch. So to start, if I hit the All Samples group here, you will notice next to each one of the samples, there's a few icons here on the left, with the last one being a box or a grid. That is the indicator of whether the sample has been compensated already. If it's empty, such as it is for the comp controls here, that means that no compensation was done on the cytometer or afterwards. If it's got a grid, it means it's been compensated. If specifically the grid is this gray color that we're seeing here, it means it was compensated on the acquisition cytometer. So if we mouse over it, as I'm doing right now, you'll see it says that the compensation matrix is acquisition defined. If it's any other color besides gray, it means it was a matrix that was created in FlowJo. Okay. So if I double click on the grid itself, that brings up this interface here, which will display your compensation matrix, as well as preview it on the sample that we are looking at here, in this case, an FMO control. All right. At the top, you see the actual spillover numbers from the matrix itself, and they're heat mapped. So the darker the color, the more spillover there was between parameters. So there is no number that is just inherently wrong. All it's displaying is how much signal was detected from the primary floor and how much was actually spilled over in from another floor. So even if it's like, say, 100%, it just means you got the same amount of fluorescence from the primary and some secondary floor. However, less spillover is better in terms of being able to resolve populations, particularly being able to pick out dim positives from background, or to isolate double positives from single positives and so forth. And so smaller numbers are generally better, but again, there is no number that is just wrong if you just look at it and say, well, that number just can't be. It's mostly a matter of then looking to make sure that it appears that each of your populations has the single positive population on any known sample. And so we could look at, for example, the comp controls if we wanted. And so this also implies that you can preview a matrix that has not been compensated yet with any matrix that is in this interface here. So the blue dots here are the uncompensated version of the parameter, and black are the compensated version of the parameter. And so if we just want to look at the compensated data, we can turn off overlay uncompensated. And so for all these, this is a single stain control for PE-Cy7, we would expect that we should actually really see a perfect alignment of background and single positive, because these should all be single positive, specifically for PE-Cy7. And when I say perfect alignment, I mean the MFI, the median fluorescent intensity of background, should equal the median fluorescent intensity of single positives. So you should be able to draw a straight line to the middle of these two populations on every channel that isn't PE-Cy7, and have that line up. And then we can preview that on other samples to see that this looks like this is still the case, that we generally have sort of rectilinear data for when we expect there to be single positives within the population. All right, and so that's what you're looking for to assess how nice a compensation looks. So when you did this calculation using an algorithm on your acquisition cytometer, there we made sure the math was correct. There we actually did a calculation, well, not we in this case, if it was an acquisition cytometer, the acquisition cytometer did a calculation to make sure that the MFI of background matched your single positive compensation controls when it did its balancing act. It's a little bit of matrix algebra to make sure that we have used our controls to properly set our compensation. And so these should all be correct for your single stain comp controls. And so what we're really just looking at here is making sure that our single stain comp controls properly matched our actual data. You can edit this matrix. It's grayed out at the moment because we consider the acquisition defined matrix part of the raw data, and we never edit the raw data in FlowJo. If you hit the edit button here, you'll get this message that effectively says, don't do this. And so I'll say, yes, I'm doing it anyway, and we'll make a copy. So we've copied your matrix so you can edit this one to your heart's content, and you still have the acquisition defined. You'll notice in the background that any file that had been compensated with the gray acquisition defined matrix now has this light blue acquisition defined copy, as we see when we mouse over it, which is this one here, which can be renamed to anything we want. So I could just call it, say, copy, for example, if I wanted. Doesn't matter too much. You'll notice the numbers on gray, and at this point you have the ability to pick a particular box, hit the up arrow to go up 1%, the down arrow to go down 1%, hit enter on your keyboard to refresh the plots. And if you hold down things like Shift, Option, Command, any of the function keys, then you're going to go up by larger or smaller increments. So I just held Shift and went up in increments of 4%, and you can see I've now dramatically overcompensated this population. And so again, the reasons to, you may want to make a minor edit to a matrix, but generally you will not want to. The reasons for this are that the matrix is probably correct when it was calculated. And so anything that doesn't look right on the actual data when a compensation matrix that was calculated by an algorithm is applied to it, probably implies that maybe something about the comp controls didn't perfectly match the data. And that's worth going back to the comp controls and looking at to see if we can fix that. One of the main reasons not to try to make an adjustment here is that what you're actually doing when you're adjusting the spillover amount between two colors is telling our algorithm there is less of a given color than was thought previously, that was calculated. And so that becomes then factored in for every one of these interactions that use a given color. And so whereas you might make one plot better, or in this case dramatically worse, sorry, you will actually probably affect many, many other plots. And so you might be able to make one slightly better at the expense of making others much worse. So one other thing that I wanted to mention in this window, if we would go into these files and say do some kind of gate. And so like, how about we'll put on a live dead gate just to try to discriminate the dead cells and remove them from the equation here. Call that live and add this to the group. All right, oops, sorry, my WebEx, my Zoom controls keep jumping in front of, let's see if I can pull that down. Yay, okay, before those Zoom controls pop up. Awesome. So at this point, when you want to preview a population here, you can look at any gate that you've made and exclude everything that you gated out. And so it may make a lot of sense to exclude the dead cells before you check to see how good a compensation matrix looks. You may see some spurious population that in fact just turns out to be dead cells. So there's good reason for using that tool there. The last control in here I'll point out is the view. And so you have the ability to zoom in and focus on one particular parameter. You have the ability to look at histograms, but I really do like the end-by-end view. Which I should point out as well, carries over the heat map colors from the top to the bottom, so you can examine the parameters that may have more issues with spillover to see if you're going to be able to resolve your populations here. Okay, so if you've already compensated, that is what you can get at. Okay, just a chat message, just trying. Okay, cool. That's what you can get at if you've already compensated. So now let's talk about compensating from scratch. Okay, so there's always a compensation group present in any of the version 10s of Flojo. And so what that's going to look for specifically is any file that you've added to the data that has the word comp or unstained. So we can double click on that group. We'll see what the criteria is, looking for either comp or unstained. Okay. If it so happens that your compensation controls match that, they'll automatically go into the compensation group. If they don't, either you can just drag and drop another file into the compensation group, that'll work, but it's kind of nice when things just happen automatically for you. And so something you could do is go to the preferences. So there's the heart in the upper right-hand corner of Flojo, preferences of the heart of Flojo. And so anything that you do over and over again, there's probably a preference that you can adjust it to do what you want by default, and compensation is no different. If I hit the preference icon, I can look at the various aspects of Flojo. I can find compensation. If I click on that, I'll see that here's where I can set which keyword and what value I'm looking for to associate with compensation. You could modify the existing ones, or you could add your own. And so if you have some other naming convention for your comp controls, add it to the preferences. The next time you start Flojo and ever after, you will automatically have your comp controls added to the comp group. So at the point where we were in the compensation group, you'll notice in the shortcut bar up top, the compensation wizard lights up. If you're in any other group, it will be grayed out. Also, you need to have at least 2 files in the compensation group, because if we only have 1 file, we are still unable to compensate at that point. Additionally, there is a cytometry band that includes the same icon for compensation that fires up the same compensation wizard. So either the shortcut bar or the cytometry band work equally well for firing up the compensation wizard. All right, so let's do it. We'll hit compensation. You'll see this green bar is going to flash at the bottom of your screen, and that is the math being done. All right, and so what has happened here? Stretching this out. Okay, so what has happened here is that the first thing that FlowJo had to do was to match each sample here, which is a single stain control, with the proper parameter. And so it goes through, let me scroll that down a little bit to get that out of the chat window in my icon. Okay. It'll go through, let's skip live dead for a moment. That will be the exception that we'll come back for to what happens if you don't agree. But picking just the next parameter here. It's going to go and look at each of the parameters, and it's going to see which parameter has a nice bright peak on it. And so in this case, APCH7 does. And so we will make the assumption that that is the comp control for APCH7. Next, we go back and look at the name of the file to see if the parameter is listed in the name. In this case, it is. We see the little green highlighting, and we get the green go circle over here on the left. And at that point, that indicates that we're pretty confident we've picked the correct sample, that there's a peak in the matching name. Both of those things are awesome. That means that one's probably good. However, if we look at the next three, we've got yellow lights. And if you mouse over the yellow light to check what the problem might be, it'll tell you. It'll say the file name of the selected sample does not appear to contain any reference to this parameter. Are you sure this is the right sample? So the yellow light makes you aware that one of those two things was not true. And so those are files that we're going to want to look at just to make sure. And so if we scroll on here to the next one, Alexa 488, we can see that it looks like there's a nice bright peak on Alexa 488, so that looks fine. If we glance up at the name, we notice that this data set, which was collected by my colleague Tim, he didn't put the X when he named the samples. And so humans who are exquisitely good at pattern recognition will see A488 and AX488 and go, oh yeah, no problem. Alexa 488, a computer which is looking for an exact match, will give you this yellow light here. And so we'll notice that the three highlighted here are all AX values. And so that's going to explain why we've got yellow lights there. So the yellow light does not necessarily mean that there is something wrong. It just implies that this is something you should give a look at to make sure it's okay. So here there's nothing actually to do for most of these. One, however, is a blank, a channel that wasn't turned on. So perhaps we don't want to use that one. So if any of these boxes, if we get the wrong sample matched up with the wrong parameter, or you just happen to leave some detectors on and aren't using them, you can click on the box and tell us which sample should have actually been the control for that parameter, or remove an unused parameter. All right, so we've done that and taken out the blank. All right, so perforin, CD30, interferon gamma, and all the associated fluors look like they work out, other than PAC blue, which we do want to scroll through at the bottom. And we see that that one's okay, and it's just an abbreviation, PB versus PAC blue. Cool, nothing to worry about there. So next we can look at these plots that happen. So it so happens that this particular data set uses unstained beads as universal negatives, or unstained cells for certain parameters that were collected using cells as the comp control. And it's totally fine to use beads and cells in compensation in the same experiment, as long as you make sure you match up beads as negatives with beads as positives, and cells as negatives and cells with positives for a given color. As long as the same particle is being used to define a particular population for the negative example and for the positive example, we're going to be able to calculate how much fluorescence of any given fluor spilled over into every other channel on a ratio basis. So the percent of the amount of signal that gets spilled over once autofluorescence is normalized by using particles of about the same size and complexity, then we're good, and we can apply that to any other particle. The ones we are applying, it'll be to cells, to any other cells within our experiment. We just don't want to have cells as the background and beads as the positive, because then we'll have different contributions of autofluorescence and we'll either over or undercompensate without knowing it. So we want to avoid doing that. But within an experiment, we could have, say, for example, PE Texas Red being compensated with beads, and Alexa 700 being compensated with cells. So here, we've made the cleanup gates. FlowJo automatically went in and looked at forward and side scatter, tried to find a nice dense population that includes the positive peak, and used the same cleanup gate for both the universal negative and our single stain example. If you happen to have the negative built right into the tube with the positive, then you will only see two graphs right here. In this case, we see three. So these look okay, but if you wanted to change them, you could double click and adjust this gate however you needed to. And same for the histogram gates. So this will just show me the positive gate. If I decided to stretch it out a little, I could do so. That's fine. I could also decide if I want to draw my own gate. I'll just do an example here, call it my own gate. Spell it wrong 3 times first, my own gate, there we go. And then there is a section up here where we can pick which gate should be used. So if I want to use my own gate, I could do so. I think I'll stick with the actual positive gate. So you'll notice it's a short list here on the positives. Only the gates drawn on the positive control are going to be included here. The negative list will be longer since theoretically any one of the files that we brought in could be a universal negative that we'd like to assign to the universal negative. I will mention that if we didn't pick up your universal negative and you want to apply it all the way across to all the samples, you can drag and drop the negative population into this test tube with the line through it, and we will fill down the entire column. All right, so let's go back to live data, which actually did need a correction. Just to demo, actually correcting something that needs it. So in this case, our algorithm is looking for a nice, bright, big, dense population, and it finds some of some really nice live lymphocytes. But this is the live dead marker. And so perhaps what we'd like to do is find some dead cells to include. And so maybe we'll move that down a little bit. Okay, we'll get a nice bright peak pop up there. In this sample then, I would like to say, actually, this is the positive, and we can use this negative right in the cell, right in the sample as our example of background. Let me get away from the zoom controls. I'll draw the gate, call that negative. Assign that negative gate that I just drew as our background gate, and we're good to go. Now we've only got 2 plots there. Okay, so now that I've set up an example of positive and negative, and again, what I'm doing with that is just making sure that I've got a background population so that I can calculate the MFI of what background is, a single positive population that I can now calculate for every parameter that isn't the one that we are controlling for, what the MFI is, and then do the subtraction, need it to set it so that the MFI of these cells for all the other colors are equal to the MFI of background. We, of course, don't want to set the MFI of these cells for all the other parameters to 0, because that would probably be overcompensating, as every cell will have some autofluorescence, every machine will have some noise, and so forth. And so that's setting these up so that we have an example of background and positive for each color interaction. When we hit go, or even at this point apply, it'll just create a matrix that will have the spillover amount from each color into every other color. We can view that matrix by hitting the View Matrix button. So there is our new compensation matrix, just as one more line item in the same window we saw before. We could go through the same process of picking out any file and previewing our matrix on that file, preview it on a particular population and so forth. Everything that we showed before works. I will mention, because I don't think I have yet, that the M here is draggable. And so if you want to apply this matrix to a file or a set of files, you can either drag it out of here, or drag it right out of here in the original creation window, or hit apply to group and pick a group. Let's show drag and drop. So from either place, you can grab the M and drag it to an individual sample. So I've just compensated that to bead comp 38, or I can drag and drop it to a group. So I've now compensated all the files in this data group, and you can see I have the red matrix, since that's the color we used. Double clicking on this, we could edit it if we wanted further. We've now switched to we're making a new matrix orange. I'm just going to show that you could name it whatever you want and color it whatever you want. Some other color, for example. And so you can build as many matrices as you want into your workspace. We will keep track of which files have which matrix. The color will do that, of course. But if you want an exact name and list, you can always hit the right click, edit columns on name. Here's a list of all the keywords, and compensation matrix is always one of the first choices, so that you can go in and see which matrix is being used. Okay, so there you have it. I think the last thing to show is at any point you can hit save a matrix, and you can export this matrix either as a FlowJo matrix file or as a CSV file. That can be dragged and dropped to another workspace if perhaps you brought the same data set into 2 different workspaces and only want to compensate once, or did 2 experiments on one day with the same set of parameters. That's totally possible. And then the last thing I should add is that for any matrix that was calculated in FlowJo, you can ask it to calculate the spillover spreading matrix. The SSM button will pop up. You can either display it or export it. So spillover spreading will tell you how much of a given signal is spreading into the other channels, and it'll give you a good measure of, will this panel that you've created, was it going to work on your cytometer? Will you be able to resolve dim positive populations from background? And if somebody else wants to use the same panel, what does their spillover spreading matrix looks like? Will they be able to replicate your work? Is it fair to say, you know, this panel should work on your cytometer, and so I should get the same results or not? So that's a relatively new edition. I believe it was put in 10.3. And so if you've got 10.2 or so, that's one of the things that'll appear if you update to one of the newer versions, which if you're on 10.3 is free to get. Okay, closing that up. All right, that is compensation and FlowJo, both if you have brought in a acquisition matrix or if you have started from scratch. So let's check the questions box here. So far it looks open. Let me also just turn on the chat to see if anybody was answering questions there. Cool. So it looks like no questions whatsoever. So we'll assume this was crystal clear. I'll hang out for a minute or two here just to see if anybody is furiously typing a question as we speak, and then I'll shut it down if not. And then mention that on our website, under the webinars, just pretty much where you found this one, is a list of recorded webinars that this one and all the other webinars that we've done over the past year or so are available for download and viewing. All right, so I think we'll stop the recording.